Hello, welcome to Solved with Danny. So we're going to solve multi-step equations, but with variables on one side of the equation. And before we hop into those, we just got to do some quick simplifying expressions, combining like terms practice, because that's going to happen inside these equations. Okay, so recall order of operations, PEMDAS, as some of you may know it as. So you've got your parentheses, exponents, multiply and divide are bundled together. It's whichever one happens first, left to right, and then adding and subtracting as we go left to right. So the first thing we're going to do is pick a different color. And if you watch my videos, you know I love to use multiple colors because it makes me happy and it's just easier to see things. All right, so we've got to simplify this out. First thing I notice is we have parentheses. We've got a coefficient out there, 3 being multiplied by that quantity. So we are going to distribute that 3 in. And for me personally, I like to circle that whole coefficient because sometimes you might have a symbol like a sign out in front of there. And then we want to multiply that whole thing in. So I always circle it, then draw my fun arrows. So 3 times x is 3x. 3 times 4 is 12. And then I'm going to bring the other two pieces down. Okay, so now, and I'm writing on my iPad if you're wondering, why is she always looking down? It's because I have an iPad down here. Okay, so now we have to look for like terms. So we have 3x and positive 7x. Again, I always circle the symbol out in front. And then we also have this positive 12 and this minus 9. So I always like to write my term with the variable first, just how I roll. So we have 3x plus 7x. That means we have 10 x's. We add the coefficients, keep the variable. We'll change and do other stuff with fun variables in a later video. Okay, and then we have positive 12 minus 9, which just means 12 minus 9, which is 3. And then that is as simplified as that expression is going to get, that binomial. All right, so let's move to the next one. Oops, I'm zooming in. All right, so still living our best life with order of operations here. Let me scooch that down. So we are going to distribute first this positive 2. And notice that I'm circling the symbol in front because you never know. Something crazy might happen. And we'll distribute it through. I'm going to drop down the other pieces that we're not touching, that 5 out front, that 11 on the end. We're not touching any of that. I'm just going to bring it down so I don't have to forget about it because sometimes you might forget about it, okay? Then we have positive 2 times w, that is 2w. And then we have positive 2 times, technically, that's like a negative 7. So where's my, so we have plus negative 14, or you could have written it as minus 14. It's the same. It's whatever floats your boat. Okay. Now we're going to look for like terms. So 2w, there's no other term that has a w in it. He's just chilling. And then we have this positive 5, this plus negative 14, this plus 11. And if you know me, best friend, I love the calculator. There's no shame in using the calculator. You get it for the whole exam, friends, okay? So we have 5 plus that negative 14 plus 11. I'm just going to pop that baby in all at once, and we get a positive 2. So to our final answer, we bring that 2w down, and then those 3 terms, when they're combined, is positive 2. Life is good. We're done. Okay. Hopefully this is feeling familiar. If not, we'll just keep doing. I have 2 more examples. So if you're feeling good, fast forward. If not, this one's a good one to watch, okay? So this one, we have 3z plus 2 minus 3 times the whole quantity, 2z plus 4. So this is the perfect reason why I like to do that little plus minus there, plus the negative, okay? And then distributing that over. So whichever way you like to write, if you like to keep it as minus 3 and then just bundle it, or if you want to keep it a negative, do plus a negative 3 and then distribute it, it's the same. Whatever works best for you, okay? So I'm going to drop down those first 2 terms that we are not using. And then we have that -3 times +2. That's going to be -6. So plus, I don't know why that plus sign's so small. A little plus sign. Okay, so plus a -6. And then we have that -3 times 4. That's going to be plus -12. Okay. I forgot something. The Z. Ooh. Did you catch me? Did you catch me? Almost forgot a variable. Holy guacamole. I was too excited about the negatives. Okay. Key example of why you should take your time. All right. So now that everything in those quantities simplified, let's find our like terms. So we have 3z. We have that plus -6z. Ooh, I don't like using red. It's an aggressive color. Okay. Then we have +2 and then plus -12. Okay. So 3z plus -6, again, no shade if you slap that in your calculator, is negative. Oh, I'm going to write this in black. Otherwise, it's like color city. I like colors, but I got a limit. Okay. So we've got -3z and then +2, and then that plus -12 is going to be -10. You can either write it as -3z minus 10 or -3z plus -10. They're both the same thing. If this was like an exam question and it was multiple choice, you would most likely see it as the -3z minus 10. But just know, they mean the same thing, okay? It's tomato, tomato. It's the same, just pronounced different. Okay. All right, I believe I have, one more simplifying expressions, and then we'll go into solving our multi-step equations, okay? So this one is a classic one. You'll definitely see this in some equations. The Regents exam loves to do it. And if you don't know me, I'm in New York State. We have the Regents exam, so I reference that quite a bit, okay? So 9 minus that quantity, what's being distributed? Technically, there's a little 1 right here. So we are distributing -1, not the 9. Okay, not the 9. Classic question right there. So if there was an example you were going to write down, this be her. Okay, so I'm going to bring down my 9. I'm going to bring down that minus 15q. Okay, so we have -1. So you can leave it as -1 or plus -1. You know, this part makes your heart sore. You do you, boo. Okay, so -1 times q. I am going to write this as plus -1q, just because that coefficient might make it a little simpler to simplify later on. Okay, and then excuse me, then -1 times 3, that's going to be plus a -3, and then I have all my other terms down. Now it's like we've been practicing. Let's circle our like terms. That -1q, that minus 15, which again, if you want to go pew pew and do plus as a negative, it's the same. And then we have the 9 and the -3. So when the dust settles, we have -1q and that -15q. That's going to give us -16q. Q's fun to write. And then 9 plus -3 plus 6. Okay, so before I get to the equations, I just want to say, if you're like looking at these, you're like, I feel like you still need some practice. If you just Google, hopefully I don't get sued for saying this, but like if you just Google combining like terms, CUTA, like KUTA, and just hit Google search, like literally the first link will be something called CUTA software. And it's like these worksheets that sometimes we use for like quick practice problems, and they always give you the answer key. They're just going to give you the final answer. They won't give you the steps in between, but it's a good way to check if you need a little extra practice. Okay, so spoiler alert, that's what we like to use as teachers. Okay, next, here's a little acronym. Maybe you've heard it, maybe not. But when you are solving multi-step equations and you have lots of stuff happening. Maybe there's variables on both sides, there's distributing, it's just like insanity. This is the acronym that I like to use to help solve those. And again, the equations we're going to solve today are variables just on one side. Okay, so this stands for distribute. You might want to write this down. Combine like terms. My handwriting will be so much nicer when my Apple Pencil comes in. V stands for variables on the same side. Okay, and then solve. And solve, that's just like your backwards PEMDAS, like we were practicing in the 1 and 2 step equation video, okay? When you do those first 3, then you should be to a nice normal 1 or 2 step equation. And then we're in happy land, all right? So take a hot sec, write this down, because this acronym is gonna help you, like a lot, all right? Okay, so, and I'm gonna keep just writing the letters of it next to it just to kind of give us a refresher. DCVS, distribute, combine like terms, variables on the same side, and then solve. Okay. Watched me solve equations before. You know I love to draw my line down on the equal sign, keep my equation in balance. Whatever happens to one side has to happen to the other. Okay, now for the first part in this equation, though, there are some like terms. So is there any distributing that we can do? No. But is there any combining like terms we can do? Yes. Yes, there are. We have positive 5x and positive 2x, and this plus 1, no one to combine with yet. So we'll just bring that down. We'll bring down our equals 50. And then I'm going to combine those two like terms. So 5x plus 2x is 7x. Okay. So now are the variables all on one side? Yes, they are. Life is good. So now we are just going to solve like our nice normal 1 and 2 step equations. So for me, I like my line down. I also like to circle my variable. Okay. And then whatever is not circled with that, I look at it, I'm like, okay, plus 1 is next to it. I don't want that plus 1. I need to do that inverse operation. So the inverse of that is going to be minus 1 from each side. That's going to cross out. Bring down our 7x. 50 minus 1 is 49. We have one last step. 7x really means 7 times x. So how do we undo multiplication? We divide. So we are going to divide each side by 7. Scooch down a little bit. Crosses that out. Technically, it makes it a 1. It doesn't just die. It's a 1. Equals, and then 49 divided by 7 is 7. And we're done. Yay, life is good. And for the sakes of this video, because I know a lot of you are just using this to be like, how do I do my homework? I'm not going to do the checks. But if you really want me to, put it in the comments and I'll make another one showing you how to do the checks. Okay, so let's rewrite our acronym for our next example, DCVS. So is there, let's draw our line down so we don't forget about it. All right, D is distributing. Do we have to distribute? Nope. So life is good. Don't have to do that. Can we combine like terms? Well, 7y is just chilling by itself, but we do have this positive 1, and we do have this positive 3 that we can combine. So let's bring down our 7y, and our equals 18. Positive 1 plus 3 is positive 4. Are the variable, so we combine our like terms. Our variable is on the same side. There's no variable on the left and the right, so life is good. And now we are just going to solve. Yay. Okay. So for me, I love to circle my term with the variable. Anything next to it, we be moving. So how do I move a positive 4? The additive inverse of that. Minus 4 from each side. That cancels out. And then we bring down our 7y. Bring down our equals. 18 minus 4 is 14. How do we get y alone? Well, we just said in the last one, the inverse of multiplication is division. So we will divide each side by 7. Cancels that out. We get y equals 2. And then we're done. All right, next problem. So I'm going to write my DCVS. And let's drop our line down. Okay, do we have to distribute anything? No. Coming soon, though. Can I combine like terms? Yes. So our variable's in the middle, but still only one of the 4 m's, only one thing with an m. We have this 6 and then -1. So again, I always circle the sign in front of the number because it's really like a plus -1. But again, you can just leave it as -1 if you like, or if you don't like, change it. Okay, I'm going to leave it. And then 4m is just all alone. So we'll bring that down, equals 21. Now, when I combine that 6 minus 1, it's 5. I could write it as 5 plus 4m, but for me, I really like to have that variable first. So I'm going to leave that as 4m plus 5. Again, the other way, not wrong, but this is a more traditional looking 2-step equation that we can solve. So it's just a little nicer if we can always keep it in that like same pattern, that same uniformity each time. Okay, variables are on the same side, check. So now we are just going to solve. So line is drawn down, circle my term with the variable. I have this plus 5 that I'm not loving. We're going to move it to the other side, but what I do to one side, I shall do to the other side. So subtract 5, pardon my yawn, from each side. And I'm yawning because I'm tired, not because this is boring. I would like to formally note. Okay. Anyway, so we have 4m equals 16. One last step. How do we get that m alone? Divide by 4. I'm running out of space, so I'm going to write m equals 4 off to the side. So hopefully now maybe we're seeing a little bit of a pattern. We can just get down to that 2-step. Life is so good. Now I'm going to rock your boat a little bit, just a little bit. So we've got DCVS. All right. Now this one, there's a quantity. There's a minus sign out front. We are going to distribute in this one. Woo! And when we were combining those like terms earlier above, what did I say is really in front of that parenthesis and between the subtraction sign? There is really an adorable little one, a little one. But and if you watch a different video of mine, I kind of allude to like mathematicians are a little lazy. So that's why we don't write everything. So you're probably like annoying, but just know it's because it comes from a heart similar to yours where I don't want to write everything. Okay. Anyway, I digress. So we are distributing that -1 to each of these. Okay. So this one's got lots of negatives. So -1 times 7 is -7. Now be careful. There's a negative out front. There's a minus sign up in here. Okay. So what I really want to think of this as is plus a -4. So now I have a -1 times a -4. A little bit nicer to see now that is going to be a +4. A negative times a negative is a positive, okay? Equals 9. Oh, and some of you are probably yelling at me that I didn't draw my line down, so we're just going to make it a little curvy. It's okay. All right. Now, not the same uniformity as above, so if you want to rewrite it as 4x minus 7 equals 9, you can. I just caution you to be careful, make sure when there's negatives involved that we don't lose a negative when we rewrite it, okay? So just handle with care. Okie dokie. All right, now I'm going to circle my 4x, and then I'm looking, I'm like, ugh, -7 is there. Just kidding, not sad. We can move that with a little +7 action on each side. So then we have 4x equals 9 plus 7 is 16. I've seen this rodeo before. Divide by 4. We get x equals 4. Life is good. All right, no combining like terms on that one. Variables were already on the same side. Fun, fun. Okay, ooh, let me move this guy a little bit. I don't want to see the other stuff. We'll just erase that. We're done with it anyway. Okay. Oof. Fraction. It's okay, because you know why? Insert angel voices. The calculator. It's going to be okay. It's going to be okay. All right. So, DCVS. Are we memorizing it? DCVS. DCVS. Okay? Embedded in your cerebellum. Some of you are like, good Lord, this woman was actually a teacher for 11 years. Yes. Yes, I was. Okay. Anyway, can we distribute? Yes, ma'am, we can. Take that fraction, distribute it to each of these. So we have 3/2 times x. Remember, that's really like a 1x. So we can make this 3/2 x, or you can make it as 3x over 2. It's the same. Usually you'll see the fractional coefficient out front. So I'm going to leave it like that. And then 3/2 times 1 again is 3/2. And then that equals 3. Man, I am not following my own rules today. I'm going to fix that. That's just going to bother me to no end. Whee. Okay. I know. Breaking the rules. Breaking the rules. Okay. So circle our term with the variable, even though it's a fraction. It's all good because calculator. Okay. And I wish I had an emulator up here to show you what I'm going to type in, but we'll get there. Okay. New channel, right? I'll ask my TI buddy. Shout out Dana Morris. Dana Morris, coming at you soon. All right. Anyway, so we are going to subtract, even though it's a fraction, we can subtract it. It's all good. Now I encourage you to write the improper fraction versus the decimal, because a lot of times you may get a non-terminating decimal. Like if this was 1/3, you get 0.33333. You want to work with fractions. Fractions are our friends. I know, sounds wrong, but they're our friends. Okay. So in the calculator, I'm going to type this in as 3 minus 3/2. Now, depending on what calculator you have, if you have the same calculator I have, if you do alpha and the little button next to it, you'll actually get a fraction there. So again, that was alpha and the button next to it. All right. So 3/2. And when I type it in like a fraction like that, it's actually going to give me my answer as a fraction. If you got a decimal, it'd be 1.5, but I'm going to write it as the fraction, which is 3/2. Okay. Now you're probably thinking, I left 7th grade math in the rear view mirror, but she's coming back to haunt you. All right. There's 2 ways. Ouch, my foot. There's 2 ways we can look at this. 3/2 is being multiplied by x, and the opposite of multiplication is division. We could divide each side by 3/2, which we totes can do because we have the power of the TI 84 CE gods at our hands. But we could also, we really want to cancel out that fraction, right? How do we cancel that fraction out? Remember, dividing by a fraction, keep, change, flip. Do you remember that from middle school? Oh yeah, is really multiplying by the reciprocal. So again, when you're dividing by a fraction, that's really multiplying by the reciprocal. So that's my personal favorite way. So we are going to multiply by, oops, as I say reciprocal, I write it wrong. OMG. Okay. Multiply by the reciprocal. Reciprocal just means flip it. All right. So pew, 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 all that stuff's canceling out. Life is good. X over here. Drop my equal sign down. Now, what's really interesting here is 3/2, 2/3 is also canceling out. Is our answer 0? No, our answer is 1. Those are all technically 1s, okay? And if you don't believe me, multiply. Because you'd be doing 3/2 divided by itself, which is 1. Keep, change, flip. It all cross cancels out. Those aren't just zeros. Those are 1s. So 1 times 1 is 1. So our answer is x equals 1. That was a fun one. That was pretty action-packed there, wasn't it? Okay. Oops, I'm drawing random lines. All right. Ooh, we got a lot of good stuff happening over here. DCVS. Okay. So And this time, you'll notice our variables are all on the right-hand side, but still on the same side. So that makes it nice. All right, first thing is, can we distribute? Indeed we can. Remember, I always include the symbol out front. That's why I like to circle it and encompass it all. Or if you're a highlighter, person, you can highlight it. Whatever. And we're going to distribute that. I'm going to bring everything else down that I am not touching yet. Whee! Okay. -4, remember that -4 is really like a -4. You can keep it just as -4, or you can do the keep, change thing. Each is fine. I like both. -4 times 5x is -20x. You might also see that as just -20x. It's the same. And then you have this -7. Remember? So a -4 times a -7 is going to give us a +28. All right, so we distributed. Now, can we combine like terms? As I hiccup, yes, we can. We have +16x. We've got this plus -20x, and this plus 28 just chilling for now, okay? So bring down my 4x, 16x plus -20. Again, there's no shame. If you need to, type it in the calculator. No one's judging you. All right. So we get -4x. It's a weird looking 4. It's fine. Plus 28. Now I'm back to that nice two-step equation land where we can solve. So I'm going to circle my variable. I'm going to move everything away from it. How do I move +28? We subtract 28. All right, 4 minus 28 is negative. Oops, let me use my black color. It's a mess. It's a mess. Okay. -24. Bring down my -4x. Just going to scooch up a little bit here. And then how do we get that alone? We divide by -4. Again, when you've got negatives, just take that extra second to not drop one. So negative divided by a negative is a positive. So we get x equals 6, or 6 equals x. You could leave it as 6 equals x. I get disturbed. I have to rewrite it. Okay. So it looks like we have one last problem. So I encourage you at this point, like, pause the video, try and solve it yourself, and then hit play and see, like, did you do it correctly? Okay. Like, challenge yourself a little bit here. Let's see if you can do it. All right. Drop my line down. Whee! Draw my DCVS. All right. Can we distribute? Yes, ma'am. Yes, we can. Circle the symbol out front. Distribute there. Drop down all the other goods. 8x is coming down. Equals 13 is coming down. That -3, -3, right? Times +2. -6, because we are multiplying, not adding, we are multiplying. Okay. And then -3 times +5 is -15. So again, you can write this as plus -6 and plus -15, or you can simply leave it as minus each of those. Okay. It's the same. It's whatever makes your heart soar. All right. Next, we are going to combine like terms. So we have 8x minus 6x. -15 equals 13 is just chilling for now. So 8x minus 6x is a pretty little 2x. Now we've got something we're used to looking at, right? Circle my variable. I have my line down. How do I move that -15? Inverse, add 15. Cancels out. Oh, I just love canceling it out. It makes me so happy. Bring down my 2x. 13 plus 15 is 28. One last step. Let's divide by 2. And we get x equals 14. All right. Well, if you challenge yourself to do it solo, I hope you did a great job. If you didn't, don't be discouraged. You just need a little more practice. It's okay. And then the next video I'm going to be making is solving variables on both sides of the equation. Okay, so good job. Hit subscribe for more. And if you have any other suggestions of topics you'd like me to cover, put them in the chat. Bye, everybody.